Hi everybody, in this video, let's look at some questions from your Form 5 at Math Chapter 2 Differentiation and Chapter 3 Integration. All the questions here are taken from SPM real paper. Now, let's look at this question. It's given that the equation of the curve is y equal to x plus 2x power negative 2. For part A, we want to find the gradient functions of the curve. So gradient functions means that dy by dx. Why do we call dy by dx as a gradient function? Because we can use this to help us to get the gradient of a tangent at a particular point of a curve. Okay, so how do we differentiate this one? So differentiate x, you get 1. Okay, and you differentiate this, negative 2 times 2, you get negative 4. X copy, and the power always need to minus 1. Negative 2, you minus 1, it become negative 3. Okay, so the gradient function is equal to 1 minus 4 over x cubed. This is the answer for part A. Now let's go to part B. So we have a straight line touches a curve at point P. The straight line is perpendicular to the another straight line, which is y plus 2x equal to 0. Okay, so y plus 2x equal to 0. It means that y is equal to negative 2x. From here, we know that the gradient is equal to negative 2. Since the question tells you that this straight line, a straight line touches a curve, this is actually the tangent of the curve at point P. Now, this straight line is perpendicular to this straight line. So what's the relationship between the gradient of two lines which is perpendicular to each other? We know that m1 times m2 is equal to negative 1, right? Okay, I just let this one be m2. And how do we get the gradient of a tangent? It's actually dy by dx, right? So dy by dx with the gradient of this line times the gradient of this line, negative 2, is equal to negative 1 because they are perpendicular to each other. Okay, so from here I know that the value of dy by dx at this particular moment is actually equal to 1 over 2. Now the question is asking us what is the coordinate of P. So we have to think, how do we get the 1 over 2? Since we know dy by dx is equal to this. So what's the x value we need to put in here so that we will get 1 over 2. So 1 minus 4 over x cubed is equal to 1 over 2. Now I'm trying to get the value of x, which will make this gradient function to be equal to 1 over 2. Okay, so negative 4 over x cubed is equal to 1 over 2 minus 1. 1 bring to the other side become minus. Okay, negative 4 over x cubed is equal to negative 1 over 2. So both sides you have negative, you just cancel the negative sign. Okay, no, now I'm going to do cross multiplications. X power 3 times 1 still x power 3. 4 times 2, you will get 8. So x is equal to cube root of 8. So now we know that x is equal to 2. Now we have the x coordinate of P. So what's the y coordinate? Since that the point P is on this curve, right? So what I'm going to do, bring the x value equal to, substitute this x equal to into this function to help me to get the y coordinate of point P. So when x is equal to 2, so I know that y is equal to 2 plus 2 times 2 power negative 2 or 2. Okay, now, so this is 2 plus 2 over, this is 2 power 2, right? So 2 power 2 like this. Okay, so y is equal to 2 plus 2 over 4. Y is equal to, so this is 1 over 2. 2 plus 1 over 2 will be 2 and 1 over 2. Now we know that the coordinate of P is actually equal to 2, 2 and 1 over 2. This is the answer for part B. Okay, now let's try another question. This question is also taken from SPM 2021. This is paper 1, section A, question 9. Diagram 6 shows the shaded region bounded by the curve y equal to x cubed minus 6x squared plus 12x minus 6. So this one is a function for this curve. And we have another curve which is y equal to g of x. So y equal to g of x, which is over here. And a straight line x equal to 2. Okay, this straight line is x equal to 2. Okay, it is given that the area of the curve, the area under the curve y equal to g of x is represented by this one. So still remember, how do we get the area under curve? So this is actually talking about here. If you want to find the area here, it's actually equal to this. So how do we get the area of under a curve? So now this, we're looking downward like this, right? So we will be using integrate y with respect to x. And this is 1, and this is 2. So 1, 2. Okay, so this is a way how do we get this area. But we don't know what's the functions of g of x, right? But the question tells us that if we integrate this, we actually will be able to get this one. Negative x cubed plus 4x squared minus 4x. And this one, lower limit is 1, upper limit is 2. We integrate this one, we get this. Or I can change this one become g of x. Now, for part A, the question asks us to find the equation of g of x. So I'm going to go backward. So from here, go here is integration. What do I need to do to get back this? So I'm going to differentiate it, right? So what I'm going to do is differentiate this one. So I know that g of x is actually equal to negative, bring the 3 go down, 3x power minus 1. Okay, 2 times 4, you will get 8. X copy, power minus 1, you will get x power 1, you don't have to write the 1. And differentiate the negative 4x, you will get negative 4. Okay, so this is the answer for part A. So the equation of g of x is equal to this. Negative 3x squared plus 8x minus 4. Now let's go to the second part. We want to find the area of the shaded region. Okay, so how do we get the area of the shaded region here? We can find the area of the region here minus the area under the curve g of x, right? Okay. Now, area of the shaded region. Now, let's forget about the area under the curve y equal to g of x first. Just focus on this curve. How do we get the area under this curve? We go downward we look downward like this, right? From the curve to x-axis. So I will be using y dx. So this is 1, this is 2, 1, 2, y dx. Y is equal to this. So x cubed minus 6x squared plus 12x minus 6. Okay. If we integrate this one from 1 to 2, we will be able to get the area of the green color one. But I don't want this whole area. I want to minus the area under the curve g of x. So I need to minus this part. So this part you don't have to find yourself because it's given by the questions. It's equal to this, right? But I'm going to use this one again. I'm going to use this one. So some students want to find them separately. It's up to you. They want to find the area here and find the area here and then take this one minus this one. So here I'm going to show you another method. I'm going to find the area under here, under the curve g of x. So I will be integrating this one with respect to x. minus 3x squared plus 8x minus 4 with respect to x. Okay, the lower limit and upper limit still the same. Okay, so since that this both having the same lower limit and upper limit, I actually can combine these two together. So x cubed minus 6x squared plus 12x minus 6 minus negative 3x squared, it becomes plus 3x squared. Minus positive 8x, it becomes minus 8x. Minus negative 4 become plus 4. I can combine these two together because they having the same lower limit and upper limit. Okay, dx. So this is 1 to 2. So now I'm going to simplify all term here. So like term we can do plus and minus. So x cubed, only one x cubed, so this one we cannot do anything, we just copy. So we have negative 6x squared plus 3x squared, so it will be negative 3x squared. Positive 12x minus 8x, you will get 4x, right? Negative 6 plus 4, you get negative 2. Okay, now we are going to integrate this whole thing. X 3 plus 1, you get 4. Okay, divided by 4 minus 3x 2 plus 1, you get 3 divided by 3. 4x 1 plus 1, you get 2 divided by 2, and then minus 2x. Okay, so this will be the area of the shaded region. Now let me continue doing it here. So here I can simplify it. So this is x power 4 divided by 4. So this one is actually x power 3. 4 divided by 2, you will get 2. 2x squared minus 2x. Okay, so I'm going to substitute the upper limit first. So 2 power 4 over 4 minus 2 power 3 plus 2 times 2 power 2 minus 2 times 2. Okay, this whole thing minus 1 power 4. Now it's a turn for lower limit. I'm going to bring the lower limit, substituting the lower limit into this function. So x is equal to 1 now. So 1 power 4. 1 power 4 over 4 minus 1 power 3 plus 2 times 1 power 2 minus 2 times 1. Okay, let me double check again. So for this part, you actually can use your calculator to help you. So what you are going to do, what I'm going to do is I'm going to key in a function here into my calculator. So x power 4 over 4 minus x power 3 plus 2x squared minus 2x. Okay, next, press calculate, and the calculator will ask you what is the value of x that you want to use. So I'm going to use 2, right? Plus 2 equal, okay, it's 0, right? 0, and then followed by minus, and then press calculate again. This time I'm going to use 1. Press equal. Okay, it's equal to negative 3 over 4. Negative 3 over 4. So negative, it becomes positive. So eventually we got the area of the shaded region, which is equal to 3 over 4 units square. Okay, that's all for this video. See you in the next video. Bye bye.